everyone, welcome to this video about how to simplify rational exponents. So before we get started, I want you to repeat an affirmation statement to yourself because oftentimes we're really hard on ourselves and that makes life kind of miserable. And one of the things that I believe is that as we're more kind to ourselves, everything in life is going to become a lot easier, including math. So take the next few seconds to breathe deeply, give yourself a little bit of love, and let's make this math easy. Okay, so when you're ready to simplify rational exponents, the first thing you need to be aware of is the fact that rational exponents and fractional exponents are the exact same thing, because a rational number is any number that can be expressed as a fraction. And so the technical mathematical term for an exponent that is a fraction is a rational exponent. But a lot of people call them fractional exponents, and either name works. So there's no difference between fractional and rational exponents. On my YouTube channel and on my website, I have a page that explains how to simplify fractional exponents, where I explain the basics of easy fractions that all have a numerator of 1. So if you haven't watched that video, I recommend you go over and watch that first, because that video explains how to simplify easy ones. And then this video is how to simplify more advanced ones where the numerator is not 1. So if you have a fraction that does not have a numerator of 1 and it's in the exponent, you basically need to split it into two parts. So the denominator of the fraction, as I explained in that other video, represents the root that you're going to be doing to the base. And then the top number just works like a normal exponent. So you can simplify this to be the square root of 36, because you have a 2 in the denominator, raised to the 5th power. So the 5 works just like a normal exponent, and the 2 tells you what kind of root you're going to do. So you would simplify that and you'd say, okay, the square root of 36 is 6. And so I would have 6 to the 5th power, which equals, I can pull out my calculator, calculate out 6 to the 5th, which is 7,776. That's one way that you can solve it. You can also solve it the other way, where you do the exponent first and then the root. So you could simplify it to be 36 to the 5th power and then square root that. That's a possibility as well. It's a little bit more challenging in my opinion, because if you do 36 to the 5th power, you get this really huge ginormous number. And then when you square root it, you do end up getting the same answer. So you can do it in either order. It doesn't matter. But the basic idea is that the bottom number is going to tell you what type of root and that you do to the number. And then the top number just works like a normal exponent. So if you had an example like this one, you could do it as the cube root of 8 and then square that, which would give you 2 squared, because 2 times itself 3 times equals 8. And then when you square that, you would get the answer 4. Or you could also do it the other way, where you do 8 squared and then you cube root that. So you could say 8 squared is 64. And if you cube root 64, you'd have to say, okay, well, what times itself 3 times equals 64? And the answer is 4. So you get the same answer either way. But I usually like doing it this first way because I think it's easier to take cube roots or square roots of smaller numbers versus bigger numbers. And you could even do this if you have like a 4th root. So in this problem, you would have to say, I'm going to take the 4th root of 81 and then cube it. And so you'd say, okay, well, the fourth root of 81 is 3 because 3 times itself 4 times equals 81. And then if you cube that, that would equal 27. If you do it the other way and you do 81 to the third power, and then you do the fourth root of that, again, it's going to be significantly more complicated because you'd have to go 81 raised to the third power, which is a really big number. It's like 531,441. But if you do the fourth root of that, which I can't do on my calculator, but you could, test out different numbers. And if you tested out different numbers to see which number times itself 4 times equaled that, you would get the same answer of 27. So you'll always get the same answer either way, and you just get to choose whichever method is easiest for you. So the reason that you can do it either way is because of the product rule of exponents. And the product rule of exponents says that if you have a power raised to a power, that you can multiply those two powers together, or the two exponents together for a simplified version of the expression. And you can also use this rule in reverse. So in this example, what I'm basically doing is I'm saying, okay, well, 5 halves, I could split that into 2 factors, where I have 9 to the 5th raised to the 1/2. Or I could also split it the other way, where I have 9 to the 1/2 to the 5th power. And it doesn't matter which order you do it, because multiplication can be switched back and forth and it doesn't give you any different results. So that's the reason why the order doesn't matter. But again, I usually like doing it this first way, where I take the root first and then I do the power. So to summarize, the way that you simplify rational exponents is that the denominator determines what type of root it is. So here we did a square root because we had a denominator of 2. Here we did a cube root. Here we did a fourth root. This one was a square root because it was a 2. This one was a cube root because it was a 3. And then we do the numerator just acts like a normal exponent. So we raised the result to 5, or we raised it to 2, raised the final result to 3 in both of those cases, and then we raised this one to 7. So you can do it that way. That's the way I prefer to do it. Or you can also do it this way, where you switch the order that you do it in. So you do the exponents first, or the numerators first, by doing these powers, and then doing the roots after that. But the principle is still the same, that the denominator tells you what kind of root you're going to do, and the numerator just acts like a normal exponent. And you can do it either before or after the root is applied. So if you want a formula to write down in your math notes, these would be the 2 formulas, and that is how you simplify rational exponents. I hope this video was helpful for you. Please comment below to let me know how easy this was for you, and then subscribe. For more help with exponents, check out my Exponents playlist here on YouTube, or go to mathtutoringonline.com to get additional help by asking a question or booking a one-on-one tutoring session. See you soon!